So in today's video, we are going to discuss some previous year questions. And here the first question is, we have to comment on the brightness of this bulb. Bulb is basically the resistance. And we have to talk about its brightness if omega value is increasing. So we have a capacitance, we have a resistance, and we have a source of EMF. And what is happening? Omega is increasing. If omega increases, 1 by omega c decreases. Okay, that means xc decreases, capacitive reactance decreases. That means total resistance, total impedance z will decrease. Okay, because the value of z is r square plus 1 by omega c the whole square under root. That means IRMS will increase. RMS current will increase. If the RMS current is increasing, the power in the bulb, what will be the power in the bulb? IRMS the whole square into R. This will increase. So power dissipated in the bulb will increase and it will grow brighter. Okay, so brighter. Okay, it will grow brighter. Now we are going for the next question. Here impedance Z, relationship between R and impedance Z is given, and we have a capacitance and resistance, and what we need to find the time constant of the circuit. Suppose this AC is removed, we are using a DC, we have to find the time constant of the circuit. Now whatever it is given, we should go ahead with it. So if you square it, you will get 1.25 r square, and value of z is r square 1 by omega c the whole square 1.25 r square. So 1 by omega c will be 1 by omega c the whole square will be 0.25 r square. 1 by omega c will become 0.5 r. So time constant formula is CR, right? Clearly we cannot find R or C individually, but the product can be found easily. Okay, we just have to multiply C here and divide 0.5 here. So CR will be 1 by 0.5 omega. 0.5 is 0.5. Omega value is given. Omega value is 500 radian per second. So time constant is 1 by 250, and we can also write 4 millisecond. Okay, 1 by 250 second, 4 millisecond. Okay, so that is it. That was also a easy question. In the next question, we have a resistor with capacitance, and in the parallel we have a resistor with inductance. Okay, and what we need to find, we have to find the total current. Total current means RMS value of the current. Okay, here this voltage is RMS value of the voltage, and also we have to find the voltage across this 100 ohm and 50 ohm resistance. Okay, so first what we are going to do, we can find current here. We can find I1, we can find I2, and what we need to do, we have to add I1 and I2. But while adding, we have to take care of the phase angle. Okay, because these I1 and I2 are phasors, we have to take care of the phase angles. So first I will what I am going to do, I will find this XC. This XC I will find. This XC will be 1 by omega C. Omega value is given already 100 and C value is 10 to the power minus 4. So XC is 100 ohm. Okay, so we have a good news. This XC is also 100 ohm. So R is, this R is 100 ohm, this XC is 100 ohm. That means the current will be leading here. With respect to the voltage phasor, current will be leading by an angle 45 degree, because okay, sorry, here current will be leading because we have a capacitance. Okay, and what will be the angle? Because both resistances are same. No, I will not call it resistance. This resistance and this reactance is the same, so current will be leading by angle 45 degree. Okay, so so I1, okay, so Z1 will be 100 square plus 100 square under root 100 root 2. Okay, and I1 will be 20 by 100 root 2. This will give you root 2 by 10 ampere. Okay, and we also said that I will draw a phasor diagram here. Okay, in the phasor diagram I will show the voltage phasor. Okay, this I1 is leading the voltage phasor, so I will draw it like this, and the angle will be 45 degree. Okay, so this is I1 and this angle is 45 degree. Now I2, to find I2 we will find impedance from here to here. I will call it Z1, Z2. Okay, so to find Z2, what will be Z2? First I will find XL. XL means impedance of this part. Okay, XL will be omega L. Omega value is given 100. Okay, so omega is 100, L is 0.5, this will become 50 ohm. Now this is also 50 ohm, this is also 50 ohm. That means total impedance will be, I will call it Z2, total impedance will be 50 root 2. Okay, so this 50 root 2 and this I2 will be 20 by 50 root 2, that will be 2 root 2 by 10 ampere. Okay, 2 root 2 by 10 ampere. Okay, now I2 is larger than I1, it is double, and this is I2. But yeah, here current will be lagging the voltage phasor. Here current will be lagging the voltage phasor by angle 45 degree. This means I1 and I2 both are at a phase angle 90 degree. So when two phasors are at 90 degree angle, we can easily find the sum, right? Phasor sum will be I1 square plus I2 square under root, and this will give you root 10 by 10 ampere. So I will be 0.316 ampere. Okay, okay, now apart from that we have to find the voltage drop here. Okay, and voltage drop here. Okay, now see, this is 100 ohm, this is also 100 ohm, so whatever voltage, it will take half of the voltage, sorry, That is wrong. Okay, it will be taking 1 by root 2 time or root 2 of the voltage. Okay, so basically I will go for the next page. In the next page, this was capacitance and this was the resistance. This was 100 ohm, this was also 100 ohm, and total voltage applied was 20 volt. Okay, so I will call it V, I will call it V. Why V and V? Because both are, this reactance and this resistance have the same value, but V square plus V square under root will give you 20. Okay, because both voltages are at 90 degree. Okay, we are doing phasor sum. Okay, this voltage, okay, voltage here will be lagging compared to this one. Okay, so V will be 10 root 2 volt. Okay, so this will also be 10 root 2. By the similar argument, this will also be 10 root 2. Okay, because this is 50, this is 50, so this will also be 10 root 2. So we did everything. Now the next question. Okay, this is the question, and okay, looks like I am missing here something. Okay, and what I am missing, this is a some information is missing. I will write that information. What is happening? We have a power generating station which is generating power at 400 volt. Okay, so V, this is for generating a station 400 volt, and power generated is 600 kilowatt. So this much power is, and this much power is generated. Also, distance, you have to supply at a distance 20 kilometer, and the resistance of the coil 20 kilometer wire. Okay, up and down, and resistance of the wire, resistance per meter is 0.4 ohm per meter. Okay, so that means total wire resistance is 8 ohm. You just multiply this thing. Okay, so 8 ohm. Okay, so that is the information we were missing. Okay, now now what is happening here? Here it is stepping up. Okay, from the power generating station, it is stepping up, and the stepping up ratio is 1 into 10. So basically here you are getting voltage of 40,000. 4,000 is the generation voltage, but at the power station we are stepping up. Okay, and what they want here at the supply voltage is 200 volt. Okay, so basically this has to be a step down, and the ratio should be, and we have to find this ratio. Okay, n1 by n2, n1 by n2 we have to find. Basically what happened, generated voltage is 4000, we have stepped it up, then we have to step it down. So it has to be a step down by a factor 200. So n1 by n2 should be 200. So that is the answer. Okay, so n1 by n2 is first question is easy, second question is also easy, 200. Okay, but what happened, I did some mistake while reading this question. Okay, what happened, now let us see, if the direct transmission method is used with a cable of resistance, this is ohm. Okay, zero point 0.4 ohm per kilometer, the power dissipation during the transmission is how much percent? So what they want to what they are asking, suppose we are not stepping up, suppose we are supplying at 4000 volt, what will be the power loss? Okay, so we can find the current first. Okay, so current will be, this is the power. Okay, and voltage is 4000 volt. Now I am using 4000 volt because they are asking what will happen in case of direct transmission. Okay, so this current will be 150 ampere. Okay, and power lost will be 150 the whole square into r, and that will come to be whatever percentage loss will be lost power by power generated. Okay, so lost power is 150 into 8 by 600 kilowatt. Okay, so what we are getting is, this is gone, this is gone, this is gone, and of course this will be 40, this will be 5, and this will be 3. So basically 0.3 or 30%. If you are transmitting without stepping up, power loss will be 30%. And if you are doing it after stepping up, there is some benefit. What will happen? If you step up, then voltage will increase by a factor 10. Voltage will become 40,000. Current will become only 15 ampere. Only 15 ampere. And if the current is 15 ampere, this loss will not be 30%. This loss will be only 0.3%. Okay. So what was the purpose of the question? We can highlight the use of a step up transformer. Okay, why we are transmitting, why are we transmitting the power at high voltage and low current. Okay, so that is it, we did the both questions. Now the next question is, we have a AC circuit right now, it is completed. Okay, and we have a DC circuit also, this is not completed right now, and omega value is also given here. Current is given, this current is obviously sinusoidal, and this current will be positive at t is equal to 0, right? And at t is equal to 0, direction of current is given. Okay, this will be positive and positive direction is this way. Okay, now I naught, here I naught value is 1 ampere, omega value is also given, and current is starting flowing with the shown direction. At this time, this time the key is switched from B to D. Okay, so before switching off, it may get some charge, right? It may get some charge due to this current. Okay, now onward A and D are connected. A total charge Q flow from the battery to the capacitor fully. A total charge Q flow from the battery to the capacitor. A total charge Q flow from the battery to charge the capacitor fully. Okay, after that the battery will charge it. Okay, and capacitance is given. This resistance is 10 ohm. Battery is ideal. EMF is 50 volt. We have to identify the correct statements. Okay, first we have to find the magnitude of maximum charge on the capacitor. Current is given. We have to find the magnitude of the charge before magnitude of maximum charge before 7 pi by 6 omega. Now see, time period is 2 pi by omega, right? And this time is what? This time is given 7 pi by 6 omega. So this t is more than t by 2. Okay, I don't know if we are going to use this information, but I just wrote. Okay, so we have to find the maximum charge on the capacitor before this. So we have to find the charge, but current is given. Charge will be given by this formula it dt, idt. idt we will do indefinite integration. Okay, I naught cos omega t dt. So you are getting I naught by omega sin omega t, and there will be no constant of integration. Okay, we have discussed this thing with purely AC circuit, with purely AC source. There will be no constant of integration. Okay, either we do it with inductance or capacitance, no problem. Okay, there will be no plus C. Okay, so Q max, this is half of the time period. So basically, actually the current okay, yes, this Q will get maximum, at t by 4. Okay, so basically we can find the Q max will occur. Okay, Q max will occur. Q max will be I naught by omega at t is equal to 2 pi by omega. This is one time period divided by 4, pi by 2 omega. At this time we will get the maximum value of the charge. So let us find the maximum value of the charge. Q max will be, I naught value is given 1 ampere and omega is 500 radian. Okay, so this much charge will be there. Okay, this is the maximum charge. So magnitude of maximum charge on the capacitor before this is this. This is incorrect. Okay, we will get this much maximum charge. Okay, now current in the left part of the circle just before this is clockwise. Okay, this time is already given. So current is already given. Okay, current so I value at t is equal to 7 pi by 6 omega we have to find it. Okay, so I naught cos omega t, I naught is 1 ampere, and cos omega is omega t is 7 pi by 6 omega. So this will give you 7 omega by 6. Cos 7 omega by 6, sorry, cos 7 pi by 6 will be minus pi by 6. Okay, cos minus cos pi by 6, that will give you, okay, this will give you what? This will give you minus root 3 ampere. Okay, minus root 3 by 2 ampere. Okay, okay, this is the current. Now the sign of this current is negative. Positive current is clockwise, so negative current will be anti-clockwise. We don't have to find the magnitude, forget about the magnitude. Okay, don't worry about the magnitude. So current in the left part of the circle just before this is clockwise. That is not correct. Okay, we are getting a negative sign, that means opposite of this, which is anti-clockwise. So this is also not correct. Okay, now let us go for C. Immediately after A is connected to D, immediately after A is connected to D, current is uh, okay, current is 10 ampere. Okay, we have to do it. Now see, once this is connected and this is disconnected, what will happen? Current in this circuit will depend on two things: this voltage also, and voltage across the capacitor also. That means charge across the capacitor also. So we will do it. Before doing it, let us find the charge on the capacitor. Okay, did we find the charge on the capacitor already? Okay, no, we did not find the charge on the capacitor. Okay, so Q at T is equal to 7 pi by 6 omega. This will be I naught by omega, right? I naught by omega means 1 by 500, and this is sine omega t. Sine omega into 7 pi by 6 omega. So see, this will become minus 1 by 2, right? So minus 1 by 2 means this charge will become minus 10 to the power 3 coulomb. Minus 10 to the power 3 coulomb. That means, see, if this is plus, here will be positive, here will be negative. Okay, but this is not plus. Okay, that means charge will be like this. Okay, charge will be like this. Okay, so I want to do this question in this page, but no problem, let us add a page. Okay, so what I wanted to say, this side is positive, this side is negative, and we have a battery like this, 20 microfarad 10. We have a battery with the positive terminal this way, this is 50 ohm, and we have a resistance of 10 ohm, and we have to find the current here. C is 20 microfarad. Okay, let us find V also. Vc will be, okay, no need to find Vc. Okay, we can do it directly. Q, this Q we found is 10 to the power minus 3 coulomb. Okay, I am not writing minus sign, I am not writing the minus sign. The reason is that I have already shown the direction. Okay, direction of charge, I mean which plate is positive, which plate is negative, I have already shown. Okay, so let us go this way. So 50, this is plus 50 volt, and this is also plus, it is increasing. So Q by C, Q is 10 to the power minus 3, and this is 20 microfarad minus IR. Okay, minus IR, R is 10, that is 0. So this will become 50, and fortunately this is also going to be 50. Okay, 1000 by 20 is 50, and it is 10 I, so I is going to be 10 ampere. Okay, so this part is correct. Okay, so C was correct. Now let us see what they are asking about D. Q is 2 into 10 to the power. So what is Q? A total charge Q flow from the battery to charge the capacitor fully. So how much charge is flowing? Okay, now see, right now this is positive, it is negative, but finally this is going to be positive, this is going to be negative, so a lot of charge should be there. So initial Q1 I will write, initially Q1 is 10 to the power minus 3C, and Q2 will be Q2 will be sorry, this is voltage. Okay, 50 volt. Okay, and Q2 will be CV, that is 50 into 20 into 10 to the power minus 6. So this is also going to be 10 to the power minus 3. So delta Q will be Q2 minus Q1. So 10 to the power minus 3 minus 10 to the power minus 3. 2 into, so this part is also correct. What happened here? Charge initially was also 10 to the power minus 3C. Charge finally is also 10 to the power minus 3C. But there the thing is polarity is different. Okay, polarity is different. That is why we are getting a lot of charge. Battery has to do a lot of thing. Okay, that's it. Now this is the question. Okay, so I believe this will be easy. In the circuit shown in the figure, inductance is given, capacitance is given, resistance is also given. They are all connected in a circuit with a AC source, and what we want, which of the following options is correct? Current will be in phase with voltage. Current will be in phase with the voltage is independent of R. Okay, if the current is in phase with the voltage, we know that it happens in case of resonance at this value, and in this case Vc VL minus Vc is 0, VL plus Vc is 0. Okay, I mean one thing is positive, so other thing is negative, equal and opposite. So in this case what happens? In case of resonance, what happens? Voltage current will be in phase with voltage is the frequency at which current will be in phase is independent of R. Yeah, that frequency is independent of R. That frequency depends on L and C. Okay, and we can find that frequency also. So this is 10 to the power minus 6. This is also 10 to the power minus 6 under root. So this should be the frequency, angular frequency at which current will be in phase with voltage, and also it is independent of R. So A is correct. Okay, no problem with A. At omega equal to 0, close to 0, current flowing through the circuit become nearly 0. So that is also correct. When omega is 0, capacitive reactance is very high. Inductive reactance will be close to 0. Okay, this will be XL will be close to 0, but XC will tend to infinity. Okay, so current will be close to 0. Okay, so overall impedance will be infinite. So this current will be nearly 0. So B is also correct. Okay, at omega very large compared to 10 to the power 6, circuit behaves like a capacitor. Okay, so that is not correct, because this is our resonant frequency. Here if it is if omega is very large compared to omega naught, what will happen? Omega L will be very large compared to 1 by omega C, and this will be very large compared to XC. So this will act like a inductive. It will become inductive, not capacitive. Okay, it will behave like a inductor, not capacitor. So this is not correct. Current will be in phase with the voltage at this. Current will be in phase with the voltage only at one value of omega, that is omega naught. Okay, current will be in phase with voltage only at this voltage. Okay, only at this angular frequency, which is not 10 to the power 4. So that part is also incorrect. Okay, now we are going to do the last question. So we have three voltages. Okay, it is like three phase AC. Okay, we have discussed, and all of them are at angle 120 degree. Okay, so this is V naught sine omega t. I will call it Vx. Okay, and Vy is 120 degree ahead. Okay, 120 degree ahead, that means V naught sine omega t plus 2 pi by 3, and this is Vz V naught sine omega t plus 4 pi by 3. So phasor sum of all three voltages will be 0. This part we discussed in some class, but that is not the question. Okay, what is the question? It is connected between x and y. So you take a connection between x and y. So let us say we have three wires. Okay, x, y, z. So you have to find what? RMS voltage. Now see, voltage phase difference between these two is 120 degree, between these two is also 120 degree, and between this and this is also 120 degree. See, 140 degree is also 120 degree. Okay, it is less. 360 minus 240 is also 120 degree. So the thing is, phase difference between all of them is independent. Okay, you take x, y, y, z or zx, phase difference is same. So vrms xy is v naught. That part is correct. Let us see how. We have to subtract. We have to subtract two phasors. This phasors and this phasor. Okay, no, that part is not correct. Okay, so we have to subtract these two phasors. So when we are subtracting, I will take the opposite of this. Okay, and this is the phasor difference. So if this is v naught, this is v naught, this will be v naught root 3. Okay, so this is not correct. Okay, and RMS value will be v naught root 3 by root 2. So this is correct. Okay, and it is independent of the two terminals, and this is also not correct. Okay, so this is the end of the class. Thank you everybody.